Hello, Carlos. This one's for you. Okay, everybody knows that Royal Rife applied a radio frequency signal across two electrodes enclosed in a glass tube that was filled with gas. The gas might have been argon or helium. Anyhow, the radio frequency signal energized the gas and it lit up into a plasma and made light. Okay, most researchers understand that the radio frequency signal that Rife supplied to energize the gas was not a continuous wave signal. Rather, it was pulsed on and off. So you would have a period of pulse off, when the tube would deionize, and then the signal would turn on, and then it would pulse off again, and then it would turn on again, and then it would pulse off again, and then it would turn on again. And this was how the signal cycled, or else you could say it gated, or else you could say it pulsed. Anyhow, this is what Royal Rife applied to his tube, and this pulsing action caused the Rife effect. Anyhow, if you look at the pulses and the tube, what you can say without too much question is that when the pulse turned on, the tube didn't necessarily light. What caused the arc across the tube, I'm going to draw a little lightning symbol here. What caused the arc across the electrodes that ignited the tube was when the radio frequency signal pulse reached its maximum. So at this point of the pulse, the tube wasn't lit yet, but when the pulse reached its maximum, that's when this electrode was at its highest positive potential with reference to the ground electrode, and that's when the spark jumped across the electrodes and ignited the tube. So with that understanding, we can see that tube ignition happened here at the most positive part of the sine wave cycle of the signal input. It also happened right here at the most positive part of the sine wave input, and it also happened right here at the most positive part of the sine wave input. Now, if we could look at these signals separately from the complete envelope of the signal, we would see a spike here cause the tube to light, spike here caused the tube to light, and a spike here caused the tube to light. Now, if you compare these two signals, you would find out that the top signal is a sub-harmonic of the lower signal, because with this configuration, the ignition pulses are completely in phase. How could the ignition pulses be completely in phase? I lost my eraser. Here it is. With the circuit configuration of an oscillator, and then however many stages of amplification, and then that drives the Fanatron tube The idea is the oscillator stage in this configuration is continuous. It never stops. The pulsing happens at the tube. The tube is pulsed on and off with an ignition voltage, and so every time the tube pulses on and off, the oscillator frequency and phase remains the same. It is not changed by the fact that it's pulsing over here. So each pulse on and off, if you take a look at this positive peak amplitude here, this positive peak amplitude here, and this positive peak amplitude here, they're all completely in phase. And being in phase, that would make them an odd harmonic. So the top wave, the spike, 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 would actually be an odd subharmonic of the oscillator frequency. That's my explanation. I sincerely hope that it's understandable and straightforward.